Okay, welcome to this session. It's the end of a long day. You guys are probably tired. I hope this will be a light and kind of fun session, not a heavy-duty one. I think that it will be relevant to anybody, no matter what your background is. Whether you're in the space that I'm in, which is kind of a more identity-focused space, or you're in classic blockchain, whether you're more of a business person or more of a developer. I think it will be interesting to think about this. And I don't think you have to be super technical to understand what I'm talking about. And there's a deep reason why you don't have to be particularly technical. So design patterns for decentralization is the topic. Now, how many of you are familiar with a book called The Gang of Four Design Patterns book? Lots of you. Okay, good. So if you're familiar with that book, you'll have some expectations about this session, and your expectations, I think, will be met. If you're not familiar with that book, it doesn't matter too much. But if you are, you'll see and hear some of the things that I say, and you'll map it to your experiences that you've had with that book a little bit. And that will be a good thing, I think. Okay. So let me, first of all, talk for just a minute about why I'm even having this conversation. Why did I submit this topic for the conference? I have been in software long enough that I'm very familiar with the way software was built back in, not so much the 80s, that was a little bit early for me, but the 90s anyway, and moving forward from there. And patterns of how software was built, the way software developers talked about the architectures of what they were building, what they thought about how systems ought to work. And there was a common paradigm that really became a big deal. First it was client-server, then it became three-tiered architecture and so forth, but very similar kinds of ideas that were baked into a lot of thinking for a number of years. And that paradigm reflected a lot of assumptions about centralization. So these are just three architecture diagrams that I went and lifted off the internet. I just Googled client server, grabbed the photos, and circled the fact that all of these architectures had in common the fact that you had this magical thing in the middle that was a server that did all kinds of cool stuff for you. Okay? So what's interesting is I did a similar search for blockchain. What do you notice? Blockchain has that same characteristic, the magical thing in the center that'll do all the stuff for you. And that's not necessarily bad. There was lots of good things about client-server architectures, but what's ironic about it is that we claim that we're doing blockchain because we want to decentralize. So if we're seeing the same kinds of pictures show up, and we're seeing the same kinds of words, maybe we're avoiding the word centralization when we talk about blockchain because we wouldn't want to, taint it with centralization dust. But maybe we're actually not building what we think we're building. Maybe it doesn't have the properties that we think it ought to have. Or that we want to be able to claim for it. And so I kind of became tuned into this phenomenon a little bit. And this is a diagram that I modified slightly from something that I shared at the last Hyperledger Global Forum in Switzerland. It's my own personal progression through arriving in the blockchain space. So when I first showed up in blockchain land, this was kind of how I thought about the world. Wow, blockchain is awesome. Why didn't I know about this stuff before? This is so cool. A global source of truth. It can store everything everywhere. And oh, cool, it's got the decentralized pixie dust sprinkled all over it too. So this is just perfect. And then evolved from that a little bit to, well, I have to admit there's some performance and scale issues with blockchain. So maybe we need to think about how we can offload certain things, okay? And then from there I went to, well, there's certain data that when I put it on the blockchain, it's actually kind of dangerous to have it there. I need to make sure it's encrypted. And then from there I went to, well, actually some stuff never belongs on the blockchain. And from there I went to, well, there's regulatory compliance and GDPR issues. Maybe that stuff should influence how we're building stuff. And from there, I realized that we were actually having some decentralization fails in our community. So that's what motivated me to have this conversation. And I hope when you walk out of this conversation, you'll be more sensitized to some of the ways that we can go wrong. I'm not saying we always do, but there's just some ways that maybe we ought to think about things a little bit different, and noticing patterns will help. Okay, let me also point out I'm not the only one talking about this kind of phenomenon, and here's a long list of evidence that lots of other smart people are talking about this same kind of issue. And I'm not going to go through all these, but hopefully some of these are familiar to you and you're nodding your head saying, oh yeah, I've heard people talking about this or that or the other. And all of those are the similar kind of an arc. Well, we're going to do everything with blockchain. It's perfect. Well, maybe there's things and caveats and so forth. So this brings me to the question I asked at the beginning about how many people were familiar with the Gang of Four book. I don't know what your experience, you are, good. A lot of other people also raised their hand. I don't know what your experience with this book was, but for me, I encountered this at a point in my arc as a software developer where I was just ready to realize that there were underlying patterns. And I read through the book and I said to myself, well, wait a minute, I've been doing this for years. And duh, that was kind of the point of the book. The book wasn't saying, we're going to reveal to you magic that you've never realized before. It was, we're going to give a name to a particular thing that we see happening over and over and over again, okay? So that's my goal in decentralized design patterns, is to say, I see a certain thing happening over and over again. Let's, as an industry, let's come up with a name for that thing, and then we can start talking about it and having a more disciplined conversation and know we're talking about the same thing. So a little bit of a, maybe this is redundant, maybe it's obvious to everybody, but these are the three reasons that I think I care about decentralization. You might add something to the list or subtract something from it, but basically I think most of us generally agree that these are reasons why decentralization could be a useful characteristic. And these are related to each other. As a matter of fact, in some cases you could say, well, the performance benefit is just because of the trust benefit or whatever. But I think these are distinct enough and interesting enough to call out as three separate items. We decentralize because we want to change trust characteristics. We decentralize because we want to change performance characteristics, or because we want to change scale characteristics. If we're not doing it for one of those three reasons, I'd be really interested to know why we're doing it. I think mostly that covers it. There might be some other corner cases too. But anyway, so let me talk about some patterns now. Before I go into these, let me point out something that I have seen several times. Jason, who's one of my colleagues that I collaborate with a lot, has pointed this out to me several times. I've heard other smart people mention it too. And that is this. The patterns that we're seeing in decentralized architectures happen to match the patterns of ordinary human behavior an awful lot. And there's a reason for that, because human society is decentralized. Now, sometimes there's parts of society that are centralized, but it's amazing how many times what we build when we're doing this highly technical blockchain thing turns out to actually be the way ordinary people get together and hold an election or whatever it is that we're doing. And so as we talk about these patterns, think about human, not technical patterns and how these map onto human behaviors, okay? So let me talk first of all about the invisible hand pattern. And these are just names that I came up with. Maybe there's better names for them too. Invisible hand, of course, is a phrase popularized by which economist? Adam Smith in the 1700s, okay? So I'm really reaching back here, but actually what Adam Smith described is an apt name for this pattern. It's the notion that sometimes you can incent cooperation without central enforcement. Now, that was an interesting economic observation in the 1700s, but isn't that exactly how Bitcoin miners work? You're creating this entire ecosystem of cooperation just by saying, well, and if you do mine and happen to be the one that gets the prize, then you get all this money. And lo and behold, a bunch of people show up and start making miners, and they make faster and faster miners because they want more and more money. And isn't that an awesome pattern? Okay? It's not only in Bitcoin miners that the invisible hand pattern shows up. How about announcing a bounty for a bug or a reporting of a vulnerability? You're not actually controlling anybody's behavior when you do that. You're indirectly influencing it because you're creating an incentive that leads people in a direction that you want to go. And the direction is responsible disclosure of vulnerabilities, for example, or whatever the thing is that you're trying to incent. Okay? Money isn't the only way that you create incentives. How about systems for reputation or karma? Some of these others at the bottom, I can tell you stories about why I think those map onto the pattern as well. Test suites is an interesting one that I've realized recently. In some of the work that I've been doing, there have been proposals, specifications about how something ought to work as a standard, and there have been competing proposals, and one of them has a test suite and one doesn't. Guess which one wins? Why does it win? Because you can show, you can claim karma, you can claim points, you can claim benefit by demonstrating that you conform to a test suite. And there's no measurable way to claim conformance if you go down the other route. You can say, well, I happen to interoperate with person one and I can prove it, but you can't say I interoperate across the board without a ridiculous amount of effort. So test suites change incentives in an interesting way. Now there's some opposites to this. Certification programs sometimes could be a form of opposite. Not always. A test suite and a certification are not that far apart. Having centralized approvals is kind of an opposite thing. And by the way, I call this an opposite, not an anti-pattern, because there's good reasons to do the other. Like all patterns in the Gang of Four book, there's good reasons to use an adapter pattern sometimes, and to use a flyweight pattern and an observer pattern and whatever that come out of the Gang of Four book. You don't use them in every circumstance, right? So we don't expect the invisible hand to solve all of our problems. It's just a pattern that has certain characteristics, okay? A little bit more about the invisible hand pattern. You're making some trade-offs when you use this pattern. Because the hand is invisible, you are sometimes giving up some transparency. And that along with that, there's a lack of precision and predictability. Theoretically, let's suppose that I had the power to circulate a rumor that the latest version of the Bitcoin mining software actually was doing some kind of an exploit and was, unreliable. Theoretically, I could change the incentives of a large set of people pretty quickly, and you wouldn't be able to predict the effect. And that's because we're depending on an invisible hand. There's a little bit less transparency than we have with some alternative mechanisms. So it's a trade-off, right? It's also possible, it's also important to note that sometimes it can be hard to change an incentive. Once you get it well entrenched, people don't want to give up their incentive, and you say, hey, I think I'm going to change the way incentives work in Bitcoin, and you end up forking the community or something because people really don't want you to change that. So that's another trade-off you're making, okay? There's some gotchas that go along with this pattern, and then one of them is that when you use this, you can actually, by the way you impose the hand, you can trigger centralization. So if I go back here, the difference between a test suite and a certification is whether you impose it. Okay? If you impose it, who's you? Whoever you is centralized. So therefore, you've given up a bunch of the benefit I'm being a little bit black and white here, and it's actually a little bit muddy. How you impose it, whether the community agreed to adopt it as a consensus-based choice or a standards organization simply decreed it. But you get the idea. You need to be sensitive to whether or not you're giving up the benefit you think you're getting by the way you actually impose the invisible hand influence. Okay, enough of that pattern. Second pattern here, a blind mediator pattern. So this is a style of interactivity where you have somebody between the two parties that really want to talk, and this between person or entity is deliberately blinded so that they can't be partial. There's several different ways that you can accomplish the blinding. And as a result, what you gain from this is you gain a certain kind of indirection, and in some cases you can gain performance, scale, connectivity, or privacy benefits by having this blind mediator. Now, just like other patterns, this pattern isn't, I'm not saying this is the end-all be-all solution to certain things. It has characteristics, and those are interesting, okay? So Tor and mixed networks in general are an example of a blind mediator. Proxy re-encryption is a cryptographic technique that's kind of a blind mediation. The agency concept that I heard a couple of talks allude to earlier today is an example of a blind mediator pattern. The opposite of a blind mediator would be something like an identity provider. When you use one of those buttons on a website that says log in with Facebook, is Facebook blind? No. I'm sorry to tell you, Facebook is not blind. They know all the places you're logging in. They are a non-blind mediator. Okay? Again, I'm not saying that blindness is always great and non-blindness is always bad, but there's a contrast. Most social media platforms, the platform is mediating between you and all of your friends and is not blind. There's some trade-offs you make with blind mediator. There can be performance and scale overhead costs to using this pattern. And it changes the trust dynamics. A two-party interaction and a three-party interaction are not quite the same from a trust perspective. That could be not the same in a good way or not the same in a bad way. They're just different. So you need to understand. For example, there's different regulatory compliance dynamics between two-party and three-party systems. Okay? Some gotchas to be aware of with this pattern. Mediators that can unblind themselves could be dangerous. And so there are ways of doing a blind mediator where you kind of depend on the mediator being blind, and there's ways of doing it where you don't have to depend on the mediator being blind because you force them to be blind. And that's what I'm trying to tease out there. You have to recognize the different possibilities. Even a blind mediator can skew the dynamics of interaction. For example, you could have a service on the internet that deliberately delays traffic coming from this part of the world versus that part of the world. It may not know much else, but that may skew something about the interaction. And even mediators may need to be audited. Enough on that one. The sharding pattern is an interesting one, and all of our crypto experts out there will nod their heads immediately at the word sharding. But it's not just cryptography where sharding shows up. As we speak, Super Tuesday is happening in the United States. That's an election formalism that's a form of sharding, so to speak. You're spreading input duties across lots of different parties. I didn't mean political parties, entities, lots of different entities who are all contributing to an answer. So there's a cryptographic version of sharding. Shamir secret sharing is a really good example of that kind of pattern showing up in cryptography. But consensus algorithms, what Alex just talked about in plenum, where you have a bunch of Byzantine fault-tolerant nodes participating in a consensus algorithm, and you can have nodes that are malicious or nodes that are down. Sharding is the technique whereby all of these nodes get some input into the overall answer, and you deliberately structure the sharding properties such that it degrades gracefully and it solves certain problems under attack. Triple signed receipts, if anybody's familiar with that, is another form of the sharding pattern. Legislatures and parliaments having, lots of different representatives that all show up and meet is really a human version of sharding. The notion in traditional authentication that it should consist of three things: something you are, something you have, something you know, is really an example of this pattern. You're not putting all of your eggs in one basket. The last one I put down is kind of an interesting one. Two keys. When you do in a nuclear missile silo, there's two physical keys that have to be turned to launch a missile, and they're deliberately placed too far apart for one human being to turn them. You can't get both keys with human reach turned at the same time. That's because they're trying to shard the responsibility. They don't want to let one person centralize the responsibility there. So the opposite of this pattern, it would be something like sharing keys or passwords. In human government, dictators are the opposite of this kind of pattern. Having overly privileged sysadmins is kind of an example of the opposite of this pattern. And having backdoors is the opposite of this pattern because it lets you short circuit the sharding. Now, sharding has some trade-offs. One of them that's maybe worth some thinking about is you're incurring a user experience burden around the process of reassembling the shards. It's great to break stuff apart. That part's easy. Putting it back together is hard. I'm not saying it's hard mathematically or code-wise. I'm saying it's hard from a user experience point of view. How do you help a person understand what's going on when they're trying to assemble all these pieces? And how do you do that in a way that's friendly and robust and resilient and so forth? It requires you to track more metadata. You don't just have to track the value, you have to track where the value is sharded and what the characteristics of those shards are, and if those characteristics change, you have to track that as well. So Facebook has a friend recovery kind of a feature where you can recover your Facebook account by sharding privileges to that account with 3 of your friends. But if one of your friends dies and one moves across the globe and never talks to you again, your sharding mechanism didn't work very well. So you're incurring a burden in maintenance around shards. The other thing to know about this on the gotcha side is when you and I've seen a number of architectures in our space miss this particular point. When you reassemble the shards, somebody now can see a view without the shards. And if you don't then get new shards in place, you have essentially undone all of your benefit. So let me explain. If you have 5 buddies that are going to all help you reassemble your identity, and your 5 buddies bring their pieces, they put them on a table, and whoever can see the table now doesn't see the shards, they see the whole thing all together, right? And once they've seen the whole thing all together, they can't unsee that. So the only way that you can preserve things across an assembly is to create new shards afterwards. That's what I'm talking about there. If you're not careful, a loss of a shard could be fatal, so you need to set up redundancy in your sharding properties, and you need to think about collusion by the people that hold a shard. Okay, this is another one that's super common in our space, in the blockchain space. We use it all the time. But we don't see the connection as a pattern very commonly, I think. So the notion that if somebody tries to mess with this, we're going to reject this because we will be able to detect that it's been tampered with, and the system automatically rejects the tampering. okay? Write once, read many storage technologies, and content addressable storage technologies have some of these properties. IPFS is an example of content addressable storage that it implements the tamper rejection pattern. The way that Git manages commits is actually an example of the tamper rejection pattern. You can change a Git commit, little known fact, but it's quite hard to change it in a way that doesn't also change the commit hash. And that's by design, and that's a very good thing. So we know whether the commit is the same one that we were thinking of. The simple act of checking digital signatures usually is evidence that somewhere there's a tamper rejection pattern that we're trying to implement and surface. Not always, but usually. Checking signed binaries before we install something. Anyway, I won't go through all these exhaustively, but the opposites of this would be trusted services or trusted oracles. So a trusted service, you're saying, look, I'm asking you to do some work and you'll just do it for me. A trusted oracle is I'm asking you a question and you'll give it back to me. Either of those is kind of an example where the tamper rejection kind of goes away. Why does it go away? Because you're asking a service, which is a central point, to do something for you, and you just have to trust that the service did it for you, right? You no longer can detect whether the service itself is tampering. You might be able to detect whether others can tamper, but you can't detect whether the service is. And the same thing for an oracle, okay? Some trade-offs and gotchas with this pattern. There's some complexity that you're incurring sometimes when you do the tamper proofing. You often make it difficult to do harmless updates. And those people like Alex who have been down in the guts of a distributed ledger or a blockchain code base really get this at a kind of an instinctive level. Like, because these things are not going to let you change anything without a new transaction, it just, you know, doing something simple like the other day, I published some documentation and then I found out that I actually didn't put a period at the end of a sentence. Not the end of the world, but since I'm picky, I wanted to go change that. And if I had published that documentation to a blockchain, doggone it, the transaction that I just told everybody was the one that had my canonical stuff in it now is different. And that could be okay, but it can sometimes be a pain. This one about upstream and downstream tampering on the gotcha side, I'd like to comment about for just a minute. SideTree is a very interesting project sponsored by the Decentralized Identity Foundation that allows you to offload a lot of traffic from slow blockchains. So what you do is you batch up hundreds or thousands or millions of transaction requests on, let's say, a Bitcoin blockchain, and you commit all of those requests as one transaction. So instead of running 1 million transactions, you run one. The problem is, and of course blockchain, I mean, we're talking Bitcoin here, it's tamper resistant and everything. But the service that batches things doesn't have to prove that it's doing anything right. And so if that's the case, then what you're giving up, and this might be a smart trade-off, I'm not saying this is a bad idea, I'm just trying to make us conscious of it. What you're giving up is the ability to reject tampering by that particular service. So upstream of the point where you commit it to the blockchain, or downstream, you can't detect it maybe, but at least at the moment of the blockchain you still can, and maybe that's a good trade-off, okay? This one is really obvious, but I've actually seen it used in some clever places that maybe aren't so obvious. Just having an unpredictable selection. So Bitcoin proof of work is based on this principle. The notion is everybody needs to mine, and there's no way of predicting in advance. You can't game the algorithm whether or not you're going to be the one that wins the mining contest and gets the Bitcoin, right? Because it's deliberately structured to be random. The peer did stuff that I talked about earlier today and carry set the value of a did based on entropy that came out of a secure random number generator. Why? So that you cannot subvert the system and steal ownership of an identifier that you're not supposed to. So that's unpredictable selection of the value of a did. If you could, today, if you go read the documentation of how GUIDs and UUIDs work, you'll see that these are algorithms that if you use like a UUID version 2 or version 3, certain parts of the UUID are predictable. They're owned by a certain entity, right? Your organization should always use the same values in here. Well, that predictability is giving up some of this pattern. And that could be a good trade-off, again. I'm just... in plenum, that Alex talked about in the session right before this, if you know who the next leader is going to be in a consensus algorithm, then you can mount follow the leader attacks. So having a leader in your consensus that's unpredictable makes it harder to do a follow the leader attack. The trade-offs here are you cannot optimize predictably if the thing that you're trying to optimize is deliberately unpredictable. And that could be a good trade-off or not. It's also difficult to audit. So an example of that concern is if, I don't know that this is true, but if some government were able to take over a massive percentage of the Bitcoin miners in the world, we wouldn't have any way to know that they had done so. It would look random to the rest of us, but it wouldn't be random to them. So this is one where you just have to kind of know that we're making a trade-off. I'll just highlight on the gotchas thing here, PRNGs, SPRNGs. Pseudo-random number generators versus cryptographically secure random number generators really are different. And if you don't believe me, go read some of the vulnerabilities that have been reported in various places. So this could be a gotcha. If you say, well, we're randomizing something, but the randomization is based on a weak random number generator, you're probably not nearly as beneficial on this pattern as you think. Strategic gossip is another pattern. I feel like this is maybe running a little bit long on and going through the patterns, so I'll just go through this fast. We do this in human behavior all the time, right? This is why you went to the dentist, you had a lousy experience, you tell your friends about it. Word spreads. Well, we can do that in technology too, and sometimes that's a useful thing to do. I see that there's a couple of bullets here that are actually wrong because they were copied from the previous slide. Sorry about that. I'll update the slides later. There's some gotchas with strategic gossip. One of the hardest ones is it's hard to quantify gossip. So you don't know whether you're working off of complete information. And that could be a bad thing or not. It just depends on the circumstances. The other thing to think about is lies can be propagated by gossip too. So you might want to combine a gossip pattern with a tamper rejection pattern, for example, so that you know that you're not propagating a lie. The rendezvous pattern is an interesting one, and every spy movie ever made practically has the rendezvous pattern in it, right? Somehow you go to the special brick in the wall and you pull it out and you leave your note in the hollow brick, and then you stick it back in there, and 6 hours later your buddy comes by and pulls the brick out and you've rendezvoused, so to speak. It's an agreement in advance that you will connect, but in a way that is really hard for other observers to co-opt or violate the privacy. And so there's some interesting characteristics about that pattern. One of the trade-offs you're making there is latency. You can't just talk to the other person on demand. And you also might be in a fragile state where you don't have any recourse. If the brick wall gets knocked down by a bulldozer, you're in trouble. So Let me get out of the specific patterns for a minute. There's more patterns. I just picked 6 or 7 that I thought were interesting to talk about here. And I just want to ask, for the last segment of this presentation, I'd invite you to think about some of these thought questions. Are you really getting the decentralization benefits that you want out of your architecture? If you don't know what benefits you want, then what did the Cheshire Cat say in Alice in Wonderland? If you don't know where you're going, it doesn't really matter which direction you go. So that's fine, but hopefully you actually have some intended benefits you're trying to get out of decentralization, and are you getting them? And what pattern should you use if you want benefit X? I know what are the reasons to use an observer pattern from the Gang of 4 book. I mean, I'm not an expert at it, but I could give you a couple anyway. And I think we ought to be better as an industry about saying, well, there's a reason why you should use the sharding pattern. Here's the trade-offs to it, and this is what you get when you use the sharding pattern. It's a reproducible recipe, you plug in these things, out come these things. And so I'm inviting us to think about that. Where do particular patterns show up that you hadn't realized before? And this is a really interesting one. Are there some classic Gang of 4 patterns that are already decentralized? And should there be decentralized versions of some other patterns? So for example, just to get you thinking there, the observer pattern is a fairly decentralized pattern in the Gang of 4 book. The command pattern has some really interesting decentralized properties, possibly, depending on how you implement it. I can think of a way to implement it that's bad and from a decentralization point of view, and one that's good. How do particular patterns decay if they're not implemented right? Should you be using, I just threw out some examples, tamper fail with your install and configuration? How many of us have blockchains where we're touting all of this wonderful properties, but the installation of the blockchain software itself doesn't require us to check signatures? Stop and think about that for a minute. If somebody has a malicious version of the blockchain software, what can they subvert? Maybe nothing. Maybe you don't care. But it's an interesting question that I'm not sure we're thinking about very well. Okay, so those are the thought questions. And lastly, I want to leave you with this. I'm soliciting input because I think that there really ought to be a book about this. And I'd love to have people teach me what you know about this topic. I think there's probably a large body of knowledge about this topic out there in this audience, in this general community. We're filled with smart people who have lots of interesting experience. But we haven't approached the vocabulary about this in a disciplined way, to my knowledge. So I think if we did, it would start becoming easier. We would look at a design and we'd say, everything's great about that, except you just need to, you just need to shard this. Or you just need to have this be a tamper rejection pattern so that we're a little bit stronger on this one dimension. We would start seeing those kinds of things and the patterns would make sense to us. With that, I think I'll go to question mode. You just made Jason's day. I love the topic of protocols, and I could talk for hours about protocols. I agree with you that protocols are super powerful and interesting. As a matter of fact, if I could get a PhD in computer science, that's what it would be on. Because in many ways, protocols allow you to take, these are kind of primitive ideas, and to take them and package them at a higher level. It's like the difference between recipes with kind of raw ingredients and recipes that already have certain things assembled. And so I agree with you. Other comments or questions?
Yeah, if I make a pattern and give some examples, the order and the pattern would be one thing.
Okay, so the question was blind mediator pattern. Do I think the auditor in?
The order.
Oh, the orderer. Oh, okay. The orderer in Fabric. Well, I'm not familiar with that component very well, but I know a little bit about how that works. And what I do know, I would say yes. But somebody who's a Fabric expert could maybe say, no, you're off, you're smoking dope. But I don't know that. I think it does. I would expect for any one of these patterns, we'll look around and say, oh, that's an example, that's an example. They're all over the place. There's nothing original here. It's calling out things that people have already been doing is all I'm trying to do. So I'm sure there's examples of lots of patterns in Fabric and Sawtooth and all the other ones. Other comments? Or Alan?
Yeah, some of your examples on the invisible hand slide confuse me because the parts of them seem centralized. Like who's going to offer the bounty for the thing? Like the centralized team that runs the thing. So maybe just because it was the first one, we spent the most time on that one. But I wonder if you could explain some of your thinking on the examples. Like the Bitcoin miner one, I get fully decentralized, that's great. But feature bounties, like, it's a centralized team that's putting out that thing, or maybe it's the community that's putting out that thing. Is that what you're thinking about?
This is what I meant when I said that depending on how you do some of these, it could break either way. If you can imagine a bounty that's kind of offered by a community collectively, like there's some kind of kitty of bitcoins or something that people can claim or whatever, that's kind of on the more decentralized variant side. And if you say, well, Fred put up a storefront and said he was going to give bounties, you're starting to get more centralized because Fred's one entity, right? Now, how you disseminate the information about the incentive could still be decentralized. How the fulfillment of the stuff is done could still be decentralized. So I don't think it's a black and white, but I agree with you. The invisible hand is an interesting one because if you are really deliberate about it and you is like one entity, you're going to subvert a lot of the benefits.
Some of it reminded me of the quadratic voting and stuff that's happening with Bitcoin and Ethereum, where they're trying to get this combination of democracy and plutocracy, making people who care about the project, but not having too many votes to one side and splitting the difference.
Yeah.
Okay, that helps.
Yeah, and so this could not, maybe there's a better name for this, and maybe if we named it more precisely and defined it more precisely, we'd find that the muddiness disappears because we've just defined it better. So this is my first attempt to name it, and the way I've named it, I think it is muddy. Or it could be.
I could say one more thing. This also reminded me of, Tor kind of operates with altruism and goodwill of the participants, but you have something now like Orchid Protocol that's trying to use a token to incentivize people for bandwidth.
Mm-hmm.
And might that be longer term sustainable because bandwidth has costs, and if you get incentivized to offer that to people, then you have it kind of goes to your blind mediator pattern as well. But it's incentivizing and compensating the blind mediators is also important.
That's a good point. And actually, the whole phenomenon of tokens and cryptocurrencies maps into these patterns in several interesting ways. That's one of them, is that they allow incentives to flow in ways that weren't possible otherwise. And that enables certain decentralization patterns. Okay, I think we're about out of time. I know everybody's tired. Thank you for coming. I'm happy to hang out and talk more if anybody wants to. The slides are uploaded to the conference agenda, although, like I said, I found an error in my slides while I was presenting, so I'll probably have to upload an update. But thank you very much.